ஸ்டார்ட் பண்ணுங்க. போட்டாச்சு. போங்க போங்க, லைவ் லைவ். ஒரு அவர் வந்துட்டாரு. நீங்க நீங்க தான் வருது. லீவ் லீவ் போட்டு திருப்பி வாங்க. லீவ் மீட்டிங் பெட்டர். லீவ் தான் வந்துட்டீங்க வந்துட்டீங்க.
Good afternoon, everyone. Sir, are you there, sir? Hello.
வீட்டு
Good afternoon, sir.
Okay, can we start now?
Sir, can we start, sir?
Yes.
Okay. Good
Am
afternoon,
I?
everyone. I invite, on behalf of the Unavailable College and Research Education Solutions, I welcome you all for the second day of the PDP program on research methodology and data analysis using SPSS. On behalf of the college, once again, I welcome you, sir.
Yes, I'm sharing the screen and just let me know if the screen is visible. Okay.
Hmm.
So, yeah, the screen is visible.
Yes, sir.
Okay. So, let's discuss about the simple statistical tools today, that is t-test and one sample t-test and two sample or independent sample t-test. I'll just please allow me to share the screen.
What, sir?
Please allow me to share the screen. Actually, I was out of the
Sir,
meeting
need
purpose.
to share the screen.
Yes.
Yes. Oh, sir, permission granted, sir. You can do.
Thank you. Okay.
Okay, sir.
Okay. So, all right. So let us see a questionnaire. First of all, we will see a questionnaire and the requirements for t-test, one sample and independent sample. So like uh, we have seen the calculation of mean. In calculation of mean based upon the 5-point scale, 7-point scale, yesterday we discussed. Now, if we see, suppose this scale, this is a 5-point scale, we can calculate the mean. Okay. But you see, when we calculate the mean, we do not know whether this mean is significant or not. Right. Suppose out of 5, we get a value of say 4.5. This is the scale 5, 4, 3, 2, 1. Okay. Now we don't know whether this is significant or not. All right. So we compare it with neutral value. Neutral value of the scale is 3. So if it is more than 3 or less than 3, it is significant. Maybe negatively significant or positively significant. But the issue is, if it is say 3.45, we may say it is significant. But if it is 3.02, It is more than 3, right? More than 3, but we cannot claim it is significant. We cannot claim it is significant, right? So how do we do it? Like how to ensure that it is significant or not? For one sample means only one column. One sample means one group, sorry, one group, which means we are not uh, bifurcating the group based on gender, or we are not classifying based on any other parameter. There is only one group. One group is like for satisfaction, for any other aspect. So like we have some variables: ambience, food quality, staff behavior, timings, prices, credit terms. So for all these we have only one group. For ambience is one group, food quality is one group. So we want to see whether for ambience, these are the variables of, suppose there is a canteen nearby a college, and the college students have rated this, the ambience of the canteen, the food quality, the staff behavior, and so on. Okay. So we consider this ambience as one group. We are not looking ambience from the point of view of male or female. Okay. We are not segregating it. When we segregate, when we classify it, then it is like it is based on the gender, like males are more satisfied with ambience or females are more satisfied, then it is a case of independent sample t-test. Okay. So in one sample t-test, we require only one variable, which is say ambience. If we calculate with food quality, staff behavior, timing, so 1, 2, 3, 4, 5, 6, there will be 6 different cases of one sample t-test. Okay. So let's look at the data that has been derived from this questionnaire. So the data is one sample t-test. Let's see. Okay, so this is the data. Now in the variable view, or at the top of the column, we can see the variable gender, ambience, food quality, staff behavior, timings, price, credit terms, and income. Okay. And if we see the variables like here, gender, ambience, all the variables have been included here. Now gender is which scale? It is categorical variable. Okay. Nominal scale. From ambience to income, they're all on the Likert scale, or we can say interval scale. Okay. So we can apply one sample t-test, calculating mean and comparing with the neutral value of the scale on ambience, food quality, staff behavior, timings, price, credit terms, and income separately. Even if we do it in one go in SPSS, all the results will be displayed separately. The results in one go will not be displayed. Okay. So now what are the commands in SPSS? Suppose we go and analyze, all the statistical commands are there. Whatever statistical technique we want to apply, the commands are there in the analyze tab. So yesterday we discussed a bit about descriptive statistics, like frequencies and descriptives. Now today we'll see how we compare the means. Compare means we compare means with the neutral value in one sample t-test, and we compare means of two groups in an independent sample t-test, testing the hypothesis. But how to formulate a hypothesis? Okay. Now, suppose I'm only checking ambience, one sample, or food quality as a one sample. I would say that Suppose here I make the hypothesis. Students are not satisfied with the ambience of the canteen or ambience of the cafe. This is null hypothesis, right? Which is denoted with as H0, null hypothesis. And alternate hypothesis is HA, that is students are satisfied with the ambience of the cafe. All right. So what is the criteria of satisfaction of students? That mean value should be more than the neutral value of the scale. Now mean value should be significantly more than the neutral value of the scale. This is very important. It should be significantly more than the neutral value of the scale. So when we talk about significantly more, we check the statistical significance with the help of certain tests. And this is like I have already mentioned, this is t-test, one sample t-test. So let us apply, let us first of all see the mean values. So we go in the descriptive statistics. In descriptives, we fill all the till credit term, not gender. Gender cannot be calculated for me. Okay. So regarding ambience, it is 4.66, quite high. Food quality 4.61 out of 5. So the values are very good. Staff behavior 4.68, good. Timing is 4.69, again very good. Price is 3.21, which is very close to the neutral value of scale, but still it is higher than the neutral value. So this is also good, but not that good. This is almost neutral. Credit terms is also not very good, but on a higher side, strongly agreed side. Now, if we see these values and we see even if we don't apply t-test, we can simply say that the students are satisfied with the amenities that are provided in the canteen. Okay. Now let's see whether what actually the t-test finds out. So in analyze, we go to analyze. In analyze, we have compare means. In compare means, first we have means. Means if we want to compare the mean of two groups, suppose males, and only comparison of mean, we are not finding whether there is a statistically significant difference or whatever. We are just calculating the mean, or we are calculating one sample t-test, which we are doing right now. We are comparing the mean with the test value, and test value is preferably the neutral value, neutral point or midpoint of the scale. Midpoint of the scale is like if scale is 5-point scale, so 5 plus 1 divided by 2, which is 3. Okay. So I will apply in from analyze, I'll go to compare means, one sample t-test, then the value is 3. And then all the variables are inserted. And after inserting all the variables, click OK. So let us copy this in the Word file. These are the results. All right. So in the results, we leave this table. And so, sorry, we leave this column, first two column for now. And let us focus on significance two-tailed. Okay. In the significance two-tailed, the value is 0.000. Okay. for all the variables: ambience, quality, staff behavior, timings, price, and credit ops. We will interpret them individually, not collectively, because one sample t-test is separate for all the variables, for ambience, for quality. So in case of all the variables, the significance value is below 0.05. Okay. So below 0.05 means the null hypothesis is rejected and alternate hypothesis is accepted. Null hypothesis is rejected and alternate hypothesis is accepted. Okay. So we accept alternate hypothesis for all. So one we have made for ambience. This will apply to all, for food quality also, staff behavior also, timings, everything. Now I have referred only one column. That is enough. It is showing the t test value of t also 3. So this column is enough. This is t value. A higher t value depicts that the difference is high. Now you can see the mean difference also here. Mean difference shows 1.66, 1.61, 1.68, 1.69, a very high mean difference, and similarly a very high t value also. In case of price, the mean difference is very less, and also the t value. Okay, so t value is a reflection of the difference of mean between 2 points. Like one is the test value and another is the actual value of mean. So if you want to test it, you want to see it, you can see, like let us open an Excel file. So let's do a small, mean difference test. These are the mean values. I paste the mean values here. So I delete the extra material, and these are the mean values for all the variables. Okay. What is the test value? 3. So putting 3 test value, and what is the difference? This minus this. Okay. So this is the test value. All right. So any doubts so far? Any question you want to ask? And do we find the same difference? No. Okay.
No doubt, sir.
So thank you. And this is the difference. Okay. So this is equal. You can just see this is equal. This shows that. And similarly, if we compare the t value also, which is the calculated value of t. So this t value is higher when the difference is high. T value is high when the difference is high. Okay. Clear? So the difference is 1.66, t value is this, difference is 0.21, difference is t value is 2.27. But all of them are statistically significant. There is a significant satisfaction with the students who use the services of that camp. Okay. Now, where do we use one sample t-test? One sample t-test is generally not used in high quality research papers. Yes, it can support the existing test. Like suppose you are applying factor analysis, you are applying some structural equation modeling, and you have an objective that you want to prove certain magnitude of your variables was high. So then you can use it along with the mean. So I today I jumped into the discussion on t-test, but the major aspect is there was a topic of hypothesis also. I wanted to like throw some light on that, the hypothesis. Now, for many people, and especially for those who are new in the research, hypothesis is generally a nightmare. Like how to develop a hypothesis. Okay. Now, we know that hypothesis is an assumption. Assumption. This is always prior to the beginning of the research. We begin the research, but before beginning the research, we have a hypothesis, generally in the descriptive study. Descriptive and of course in experimental. Right. Now, there are basically two types of hypothesis. One is null hypothesis and second is alternate hypothesis. Null hypothesis and alternate hypothesis. Now, null hypothesis is basically when we show that there is no difference, no relation, no association, no impact. Okay. When we write in this language, there is no difference, relation, association, or impact. You can say or impact. That is called null hypothesis. When we say there is a significant difference, relation, association, or impact, this is called alternate hypothesis. So null hypothesis and alternate hypothesis are actually depicted in this way. Right. So let's take a few examples. And before that, it is important that alternate hypothesis also has two types. Alternate hypothesis is either directional or non-directional. Okay. So directional and non-directional. Now I'll tell you what is the difference between directional and non-directional. Now, if we see that, if we write that, suppose let's take an example of satisfaction of males and females. So what is my null hypothesis? We denote it as 0. There is no difference between the level of satisfaction between the males and females for level of satisfaction towards the food quality, suppose. So it simply means that girls and boys, males and females have same perception for the food quality, same level of satisfaction for the food quality. Okay. Same level of satisfaction for the food quality. Now, when we write an alternate hypothesis, that is, there is a significant difference also. Significant difference between the males and females for level of satisfaction towards the food quality. This is alternate hypothesis, but this is non-directional. This is non-directional. Okay. There is no direction in this hypothesis. Why there is no direction? Because the level of food quality of males may be higher females may be higher. Still, this hypothesis will not tell us, even if it is significant, we will not know whether males are more satisfied or females are more satisfied. Okay. So we make a directional hypothesis as per the requirement of our study. So we can make like the level of satisfaction of males for food quality, or satisfaction for food quality is higher for males than females. So we say that males are more satisfied with the food quality of the canteen as compared with the females. Okay, that is directional hypothesis. Now, this is what if I want to prove it. If I don't want to prove it, I should not take the directional hypothesis. Okay. If I want, what is the objective of my study? My objective of my study, suppose, is that I'm targeting more on males, whether more males are satisfied or not. So I would make a directional hypothesis. Okay. So generally,
time I know. Yeah, சாப்பாடு என்கிட்ட இருக்கு. வாங்கிட்டு அப்படி வர முடியும் தானே, சொல்ல வேண்டியது தானே. எனக்கு ஒர்க் ஒன்று இருக்கு வேற. புட்டு தண்டிங்களா? அப்ப வரும்போது சொல்ல வேண்டியது அப்படி வாங்கிட்டு என்ன சீக்கிரம் வரணும். எதுக்காக வரணும்னா, என் கிளாஸ் கூட தான் பிடிக்கிறேன். அவங்க எல்லாம் முடிச்சிட்டாங்க. எக்ஸல் ஷீட் பிடிக்கிறோம். இந்த 13 நாள் லீவ் போட்டாங்க. ஜூலை 1ல இருந்து 31 வரைக்கும் இந்த 31 நாள் காலேஜ் இருக்குல்ல, இந்த சைன் எரர் டிடெக்ஷன் ஆகி மிச்ச கிளாஸஸ் இருக்கும்.
hello. Shall I continue? Am I audible? Hello. Am I audible?
Yes, sir.
Okay.
Yeah, audible, sir.
Okay, fine. So I was saying that directional hypothesis will take only when it is our objective. So generally what we do is like, suppose I make a hypothesis, there is a there is no impact of employee satisfaction on employee retention, or say loyalty. Okay, employee satisfaction or employee retention or loyalty. We can say employee retention. This is null hypothesis. When we make an alternate hypothesis, I am interested on positive impact only, not the negative impact. Okay. So if I write a hypothesis, there is a significant impact of employee satisfaction on retention. This is non-directional hypothesis, because impact can be, I will share this file with all of you. Okay, so impact can be either positive or negative. Impact can be either positive or negative. Okay. So if I say there is no impact, all right, so it can be positive or negative. So I want to, but I'm not interested in negative impact. Being an employer or being whatever, a consultant, I'm not interested in negative impact. I want a positive impact only. If it is not positive, be it neutral or negative, that's of no use for me. Okay, so what I'll do, I'll make This is also denoted with HA. Then I will make a hypothesis. There is a positive impact, significantly positive impact of employee, and this is a directional hypothesis. Okay, so this is a directional hypothesis. Either I will keep this or I will keep this, any one out of these two. Okay, I cannot keep both of them because there is no sense of keeping both of them. So I'll say there is a significantly positive impact on employee satisfaction on employee retention. Okay. Similarly, like the impact of advertising on sales and impact of promotional strategies on sales, and right. Okay. So now, having done this, if I go to the first set of hypotheses, this one, keeping aside the directional, non-directional phenomena, if I want to apply a statistical technique to compare these two groups, so whenever we compare two groups, we have a typical statistical technique called independent sample t-test. What are the independent samples? Two samples which are not dependent on each other, different from each other, like males and females. So males and females are distinct two samples. They are not dependent on each other. They have their own perception, satisfaction, everything, right? So when we compare them, we require the application of independent sample t-test. So what is the typical requirement of independent sample t-test? I'll make a small table. I think I should make a table here. यहाँ पे we'll make a table. So this is DB, IDB, independent variable. That independent variable should be categorical with two categories. Okay, categorical and what should be dependent variable? It should be metric, interval, or ratio scale. Should be either on interval scale or on ratio scale. All right. Okay. Now next we see if there are more than one categories. This is for independent sample t-test. Same case, if we write here, two categories means gender is the variable and two categories is male and female. This is the case of two categories. Now, if there are three categories, more than two, like there are workers, suppose skilled, semi-skilled, and unskilled. So there are three categories, more than two. Okay. So in this case, t-test will not work. Here ANOVA will work. So we call it one-way ANOVA. One-way ANOVA means ANOVA that is with one way means one independent variable. Okay. One independent variable, that is called one way ANOVA. So dependent will be same, metric, ratio, or interval. So this table tells us which statistical tool is suitable in which particular condition. We can keep it for records. I'll share it with you. So it will be easy for you to at least understand the requirements of these two statistical tools. Other requirements are there, like for ANOVA, the group sizes should be same, or the variance of the group should be same. There are other requirements that slowly and steadily we will understand. So now this is the case. We have two categories like gender we have, and our data is on metric scale, which is interval scale. Okay, interval scale data. So we can apply, see, this is the data of gender in the SPSS file. We have income also, like high income, low income, or medium income. So we can write here high income. This we will use in future. Medium and low income. Okay, fine. So this is our case of ANOVA. We will take it later, but now we are discussing about the independent sample test. Okay. All right. Sorry for the inconvenience. Okay. So in this, we have this data set first. So we will apply for gender, we will apply the independent sample t-test. Okay. Now, what are the requirements of independent sample t-test? Sorry, not requirements, but yeah, any questions? Any question? No.
Sir,
Yes, ma'am.
sir, Soumya.
Sorry.
Sir, actually, I have a doubt in the thing. Sir, why we are always
Yeah,
using
please.
a one-way ANOVA instead of the two-way ANOVAs?
Not
Because
always,
whenever
ma'am.
we are taking a variables, we are preferring only the one-way ANOVA comparing to the two-way ANOVA. In some occasional only we are using the two-way ANOVAs. So can you please
Yeah.
give the
Okay.
differences, sir?
Okay, please. So let me write here two-way ANOVA. Okay. For two-way ANOVA, there are two categorical variables. Suppose we want to see two impacts like gender as well as income. Okay. Then there is a case of two-way ANOVA. Gender as well as income both at same time, not separately, combined effect. Okay. I'll show you in the SPSS how what is the problem. So when we see the combined effect of both, then we go for two-way ANOVA. Here it is same. The independent variable is same. Okay. So if you, there is a purpose of two-way ANOVA. Suppose we want to see whether gender as well as income combinedly affect the satisfaction level of the girls and boys, then there is a case of two-way ANOVA. Okay. So this we have to decide. Generally, we take the impact of one variable. See, this is nothing but a kind of multiple regression. This case. Okay. In multiple regression, this variable is not categorical, but it is metric, interval or ratio. In simple regression, it is categorical. That's the only difference. Okay. So hope this is clear, right?
Yes,
So
sir.
combined effect also comes. I'll show you the combined effect also. So first we will apply the t-test. Okay, Radha ma'am, how long we can go? Like this is 3:30. So another 10 minutes, 10-15 minutes.
What, sir?
How much more time do we have? Another 10-15 minutes we can go?
10-15 minutes we can have, sir.
Okay, fine.
Okay.
All right. So I go to analyze. In analyze, I compare the means. Now independent sample t-test. In the independent sample t-test, I put all the test variables. Test variables means the ambience, the satisfaction, the this and that till credit terms. In grouping variable, I put gender. Gender is grouped between 1 and 2. It will ask for the group values 1 and 2. Okay. So then we click OK. So this is the group statistics, which is mean basically, nothing else. Comparative mean. Comparative mean of like males and females for all. Okay. Now, from this huge table, the useful thing is significance two-tailed. Significance two-tailed is like feedback of students, feedback, staff behavior, timings, price, all these are significant or not. Now, there are two values of significance. This is quite cumbersome, so I will tell you later about this. But let us understand first. You can take either the first one or the second one. Generally, there is very less difference. Either both of them are significant or none of them is significant. So let's see. Let's take the price part. In case of price, the value is below 0.05. In all other cases, the value of significance is above 0.05. Okay. So only for price, it is significant. Right. Now, for price, our null hypothesis is rejected and alternate is accepted. So how do I write it? I write it. There is a significant difference between males and females for price of the canteen products. Okay, I can write this, but whose satisfaction is more for price and whose satisfaction is less? Okay, whether males are more satisfied or females are more satisfied. So we have to first see the mean difference, males and females for price. Males have 3.01 and females have 3.47, which shows that mean of females is more than mean of males. It means males are more satisfied with the price. Sorry, females mean is more. Huh? Females are more satisfied with the price as compared with the males. Okay. Females are more satisfied with the price as compared with the males. Right? Females are more satisfied. So this is clear now. I could make an alternate hypothesis also, not directional also, but this is fine, I think. This is my conclusion. Okay. Now, suppose there is a case of, for all others, there is no significant difference. Mean difference is there, but statistically not significant. So I'm not bothered about that. Suppose it is the case of income. the students that come to a university belong to different income classes. Like some of them may be very rich, some of them may have mediocre income, some of them may have the high income. Maybe a low income. So when we see, when we compare their incomes, their satisfaction with the income. Maybe suppose one who has less income is not satisfied with the price. This is our perception, right? Not satisfied with the credit terms. But there are three categories. So for three categories, we go for one way ANOVA. So in analyze, compare means we have one way ANOVA. Okay. I tell you, one way ANOVA gives you the choice of inserting one independent variable at a time, not two independent variables. If there are two independent, then it is two-way ANOVA. Okay. So there is a rule. Now we fill in the feedback and everything in the dependent list, income in the factor, and click OK. Now, if we see clearly, in case of we have our independent is income, you see the significance. Now, under the significance column, it is 0.4, 0.6, 0.6, 0.3, 0.005 for price. So below 0.05 is only one price. Rest all are above 0.05. So if p-value is above 0.05, null hypothesis is accepted. And if it is below 0.05, null hypothesis is rejected. It means there is a significant difference. So in case of price, if I write, there is a significant difference among the various income groups for price. There is a significant difference among the various income group for price. Okay. But does it serve my purpose? My purpose is fulfilled, or there is some issue in this? My purpose is not fulfilled. I want to know which group is more sensitive for price, whether low income group, high income group, or medium income group. So I want to know the difference. So one way of knowing the difference is comparing the mean values. So we can compare the mean values. In ANOVA also, there is an option of descriptives. In ANOVA, in SPSS, there is options tab. In options, there is a tab descriptive, continue, OK. So these are the mean values. Mean is written here, MEAN, mean. For price 1, 2, 3, the mean of 1 is 2.91, mean of 2 is 3.68, and 3 is 3.18. So 1, 2, 3. So let's say, let me see how I have coded that. Income has not been coded. So I can say that, okay, the 1 means low income group, 2 means medium income group, and 3 means high income group. Okay. What are the mean values? For the factor price, the 2.92, 68, and 18. 2.92, 3.68, and 3.18. 18? Okay. Yeah, 18. All right. Now we see that medium income group is highly satisfied with the price. but low income group is less satisfied. High income group is also less satisfied with the price. I don't know why, but they are. Now we have to find out the difference, okay? Whether this difference is significant or not. Now t-test, since compares two variables, this can show that males are more, females are more, but we have to, now I cannot tell you that 2.92 and 68 is significant, 68 and 318 is significant, 2.92 and 3.18 is significant difference. So we have to compare all the groups. We have to compare 1 versus 2, 2 versus 3, and 1 versus 3. We have to make 3 comparisons. And for 3 comparisons, there will be 3 significant values. There will be a significance value for this, significance for this, and significance for this. 3 significance values for 3 groups. So ANOVA alone cannot do it. We have to apply a different statistical technique under ANOVA, which is called post hoc. In post hoc, generally I go for Tukey. TUKEY, Tukey. Continue and OK. So this table gives me one-to-one comparison. Do not get scared. SPSS gives long tables, but don't worry. We have only 1 or 2 things to check actually. Go to the significance if you can see somewhere. This is the multiple comparison. Multiple comparison, Tukey HSD. Tukey HSD. Okay. So Tukey HSD is, Tukey is the name of the person. HSD is honestly significant difference. So this test tells you whether there is honestly a significant difference or not, or it is just by chance. So in the next session we will do two-way ANOVA. Today only we will do one-way ANOVA. Okay. So now go to the significance. All the significance I see is above 0.05. In fact, I need not take the significance of the other things like except price. In price, I see 0.004. This is significant, which means 1 to 2 is significant. Okay. Shall I copy and paste this? See. First of all, I should delete all the extra variables which are not significant at all. Post hoc I do for the variable which is significant initially. So initially only price is significant. So I will do post hoc only for the price. Now you see here it is 1 and 2. And here is the significance. So this is significant. Okay. This is same thing. 2 and 1 significant. Same thing. I compare 1 with 2 or 2 with 1. One and the same thing. Okay. 1 with 3 is 0.399. There is no significant difference. 3 and 2. 2 and 3 in one box. 0.080. This should be below 0.05. So this is also not significant. So only relationship significant is 1 and 2. Rest all are not significant. This is significant. Yani difference of, we can say, final conclusion is the satisfaction of, now more or less we know by the mean values, medium income group students is significantly higher than the low income group students. Okay, low income group students. In the rest of the groups, there is no significant difference. So the only significant difference is low income and medium income. Medium income are satisfied with the price, but low income are not satisfied with the price. With low income and high income, no difference. Medium and high, no difference. Okay. So that's all for today's session. Any doubts you can ask. Yes, anybody please? If you have any doubts, you can ask.
Ma'am. Yes, sir. This is Gayatri from Accounting Finance Department, sir.
Yes, yes, madam.
So we are so thankful for this informative and effective session, sir. So we will go with the next section, I think so.
Yeah, sure. Thank you. Thank you very much. All the notes, whatever I'm noting down and data files, I will share. Okay. So that you
Yes,
people
sir.
can practice.
I can't say. Pardon?
Okay. I'm saying the files, Word file and data files I will share so that you can practice later or you can share with your students also.
Sure, sir.
Yeah,
Okay.
sure, sir.
Thank you.
Sure. So yes, so we will go with the next session. We will see, sir. Thank you, and thank you for
Thank
your
you.
wonderful.
Thank you.
Yeah.